p orbitals have a node at the nucleus because their angular wave function changes sign and is 0 at that point. So the overall probability density of finding an electron at the nucleus is 0. Think of an electron cloud like a three-dimensional wiggle described by a math function called a wavefunction, which tells you how likely an electron is to be in different places. That function splits into a radial part that depends on distance from the nucleus, and an angular part that depends on direction. For p orbitals, the angular part looks like a positive lobe on one side and a negative lobe on the other. And right at the center where those lobes meet, the angular function crosses through 0, so the full wave function is 0 at the nucleus. Since the probability of finding an electron is the wave function squared, if the wave function is 0 at the nucleus, the probability is 0 there, which is what we call a node. The sign change of the angular part is what forces the wave function to pass through 0 at the center, independent of the radial shape. A common mistake is thinking the node exists because the electron cannot be at the nucleus for energy reasons. But the node is a feature of the shape of the wave function, not a statement about energy. And remembering that the angular part determines direction helps avoid that error. Another misconception is assuming all orbitals behave the same way at the nucleus. For example, s orbitals do not have an angular node at the nucleus because their angular part is constant and non-zero. So keep in mind which part of the wave function creates the node. A short tip is to picture p orbitals as two lobes with opposite signs meeting at the center. That visual helps you remember why the value there is 0. Check out our website, www.gumballdegree.com, to find more videos and resources on this topic.